Hello, if you can turn to page 3 of your Unit 5 packet, we're going to take a look at systems of equations. And the systems we're going to take a look at in specific today have two variables. So let's take a look at number 1. Now, it says, what are the solutions to the system of equations shown below? So really what they want us to do is they want us to figure out what values of x and what values of y could we substitute into both of these two equations so that both equations would hold true. Okay, so we're going to do this using a method called substitution. Now, if you take a look, see the second equation right here where it says y equals 2x? Since y equals 2x, we can take this 2x and substitute it in for y into the first equation because we're saying here y is the same thing as this. So let's replace the y in the first equation with this 2x. Okay, so again, we're taking this 2x and we're putting it where we see the y into the first equation. So now instead of x squared plus y squared equals 5, we have x squared plus 2x squared equals 5. Okay, now all we're going to do is solve this equation for x. All right, let me move this up and give myself a little more room. All right, so I'm going to bring down this x squared. And then if I square what's in the parentheses, right, 2 squared is 4. And x squared is x squared. So I'll have plus 4x squared equals 5. All right, so when I combine my like terms, 1x squared plus 4x squared gives me 5x squared. And I'm going to bring down the equals 5. Now, I could go about solving this one of two different ways. A lot of times when you have a square, right, we bring everything to one side of the equation, we set this equal to 0, and we factor, and we make a t-chart and solve. But I'm going to go about it a different way, because since we only have this one term that contains an x, I'm just going to divide both sides of the equation by 5, right? So these cancel, leaving me with x squared equals 1. And then to get rid of a square, we just take the square root. So a square and a square root cancel each other off, so I could bring down the x. Equals. Now, remember, even though the square root of 1 is 1, this square tells us that we could have two answers. So we're actually going to wind up with x equals positive 1 and x equals negative 1. So I'm going to write x equals plus and minus 1. Okay, so these, I'm going to just branch this off for a minute. These are the two x values we have. X equals positive 1 and x equals negative 1. Okay, I'm just going to emphasize those for a minute. So these are our two x values. Now, the reason I branched them off, if we were just solving for x, we could leave our answer like this. But remember, we want to figure out what values of x and y would make these equations hold true. So we have to figure out what y values correspond with each of these x values. Now, you can use either one of these two equations above. I recommend using whichever one looks easier, simpler, right? So this one on the bottom looks easier to me to solve for y. Y equals 2x. So under this, I'm going to write, let me just separate these. Y equals 2x. Now, in place of the x, right, y equals 2x. In place of this x, I'm going to substitute it with 1. So y equals 2 times 1. And isn't 2 times 1 just 2? So y equals 2. This right here, I'm going to write this as a coordinate. I'm going to take this x value and this y value and group them together. Remember, when we write a coordinate, we write x comma y. So I'm going to put x comma y, 1 comma 2. This is one of my solutions. Okay, now we have to figure out what y value corresponds with an x value of negative 1. So again, I'm going to use this same equation. This one's just nice and straightforward. Y equals 2x. So y equals 2 times, and this time the x is equal to negative 1. So y equals 2 times negative 1. And since 2 times negative 1 is negative 2, we get y equals negative 2. So this is the y value right here that corresponds with an x value of negative 1. So to write that as a coordinate, remember a coordinate is written x comma y in parentheses. Don't forget those parentheses. So we could write that as negative 1 comma negative 2. Okay, so you could either, these are our two answers. I mean, if you were to take this coordinate, right, 1 comma 2, and plug in 1 for x and 2 for y, watch, I'll show you. 1 for x and 2 for y. 1 squared plus 2 squared equals 5. That's true. 1 squared is 1. 2 squared is 4, and 1 plus 4 equals 5. And then if I check it in this equation, right, if I substituted the 1 for x and the 2 for y, 2 is equal to 2 times 1. So this checks. So this is one of our answers. And if you checked this x and y value as well, they would check out in both of these two equations. Okay, so if we look at the answer choices, we could see it cannot be choice 1 or 2, right? Those only give us x values. We want to solve for x and y. So if you're looking between choice 3 and 4, you can clearly see that choice 3 matches up with our answers. Okay, if you can turn to the next page, page 4, we're going to take a look at number 3 on the top of that page. Okay, so this time it says the graphs of the equations. They give us two equations, y equals this, and they give us this equation, are drawn on the same set of axes. One solution of this system is, now we could do this graphically. We could plug this into our calculator and look for the points of intersection. But today we're going to talk about solving systems algebraically, so we're going to do the same thing we did in number 1. Now let's look at this. Since y is equal to this right here, can't we take what y is equal to and substitute it in for y into the other equation? Okay, so since we know that y is the same thing as this, we can take this and just replace the y in the other equation with what it's equal to. Okay, so in place of y, I wrote x squared plus 4x minus 1, and then I brought down the plus 3 and the equals x. So now we have an equation with just one variable, so we're going to solve for that variable. Okay, so since we have a bunch of x's in the equation and we have an x squared over here, I know I need to get this side of the equation set equal to 0. So I'm going to subtract x from both sides of the equation. Okay, so now I have 0 on the right-hand side. And when I combine my like terms on the left-hand side, right, x squared doesn't combine with anything. 4x minus 1x would be 3x. And then negative 1 plus 3 is positive 2. Okay, so now I'm just going to factor this. I mean, if you prefer the quadratic formula or completing the square, you could do that. But this is a pretty straightforward one to factor. So because we have a 1 in front of our first term of the trinomial, we just set up 2 sets of parentheses. And don't forget to bring down the equals 0. And since this is an x squared, we're going to put an x in the first spot in each parenthesis. And we just need to come up with two numbers that multiply to positive 2 and add to positive 3. And that's what we're going to put here and here. All right, so we have positive 2 and positive 1. And when we make a t-chart to solve, we wind up getting x equals negative 2 and x equals negative 1. Okay, now I'm just going to kind of emphasize those. Those are not my final solutions, but we're partway there. Okay, now what we have to do is we have to figure out what y values correspond with each of these x values. And you can use either one of these two equations. It doesn't matter. I mean, in this equation, y is by itself. And in this equation, there's no like squareds going on. Either one is fine. I'm going to use this second equation. I'm going to use y plus 3 equals x. Now, instead of putting, right, I'm using this one right here, y plus 3 equals x. Instead of putting x, on this side of the t-chart, x is negative 2. So I'm going to put in negative 2 in place where the x would be. And we just have to solve this for y. So let me subtract 3 from both sides of the equation to get the y by itself, and it leaves me with y equals negative 5. Okay, so when x equals negative 2, y equals negative 5. I'm going to write that as a coordinate, negative 2, comma, negative 5, in parentheses. And remember, the x always comes before the y when you write a coordinate. Now, that answer choice is not there. They want to know one solution. Okay, so this solution isn't there. So now let's find this one. Okay, so again, I'm going to use this equation, y plus 3 equals x. So y plus 3 equals, and in place of this x, I'm going to put -1. And when we solve that for y, right, let's subtract 3 from both sides of the equation, leaving us with y equals -4. We see that the y value that corresponds with the next value of -1 is -4. And if we want to write that as a coordinate, it'll just be -1, -4. Let's hope that one is there. And when we look over, yes, it is there. Right there, choice number 2. Now, one thing I just want to point out, and I'm sure most of you have realized this, but because this is multiple choice, we could have just taken each answer choice one by one, right? Taken this x value and this y value and plugged it in for the x's and the y's into both equations to see which one checked. But I just wanted to do these by hand because a lot of times they are not multiple choice, and we want to learn the process as to how to do this. Okay, so let's take a look at one that is not multiple choice. So if you can turn to the next page. Let's take a look at the one on the bottom of this page, number 6. All right, so this one actually starts off a little different because if you look at our two equations, right, we don't have x or y by itself in either one of these two equations. So the first thing you want to do, it doesn't matter which one you get by itself, but the first thing you want to do is you want to either get the y by itself in one of these equations or the x by itself. I'm going to give you a heads up, always avoid the equation that has a squared in it. I would not try to get one of these variables by itself because then you're going to have square roots within it. It becomes a mess. So look at the equation that doesn't have the squares in it. So if we look at this second equation, personally, I think it's easier to get the y by itself because if we wanted to get the x by itself, we could divide both sides of the equation by 2, but then we're going to have fractions over here, and I don't want that. I mean, you could do that if you want, but I think if we just subtract 5 from both sides of the equation, like that, it'll leave us with y equals 2x minus 5, and then we're not dealing with fractions or anything. Okay, so let's think about this. If y equals 2x minus 5, that's what y is equal to. Can I take this 2x minus 5 and substitute it in for y into the other equation, right, into our first equation right there? Okay, so basically we're going to have x squared plus, and instead of the y, I substituted it with the 2x minus 5, and then squared, and then equals 25. All right, make sure you put this in parentheses. So let's solve it. All right, so I'm going to bring this x squared down. Now remember, when you have a binomial, 2 terms being squared, you are not allowed to just distribute that square onto each term. Okay, you can only do that if you have a monomial, 1 term in the parentheses. When we have 2 terms, right, separated by an addition or subtraction, when something is squared, it means we have 2 of them. You have to take that, and you have to write this out twice. All right, so let's write out the 2x minus 5 twice. Oh, all right, well, there's my phone, so give me 1 second. All right, that was Miss Carter. So I am back, and I'm going to just keep solving. So let's bring down the x squared and the plus sign. And then here we're going to have to double distribute. So 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. Negative 5 times 2x is negative 10x. And negative 5 times negative 5 is positive 25. All right, we're going to bring down the equals 25. Now, I know I have to combine like terms, right? And I also know I have to get this side of the equation set equal to 0. So I'm going to do that all at once. I'm first going to subtract this 25. And I'm going to do it from both sides of the equation. So I'll put it here as well. So we know on the right-hand side, right, we have 0. That cancels off. Now, when we combine our like terms on the left-hand side, right, let's do it. X squared plus 4x squared would be 5x squared. And then negative 10x and negative 10x would give us negative 20x. And actually, look at this. 25 minus 25 just cancels. All right, so now we have to factor. Now, when we have 2 terms, right, the only thing we could do to factor is either factor out the greatest common factor, or we could do dots difference of two squares. This is not a difference of two squares. These are not perfect squares, okay? So we're just going to factor out our greatest common factor. So the greatest common factor is a 5x. And when I factor that out, it will leave me with x minus 4. Let me bring down the equal 0. All right, so now let's make our t-chart and solve. So on the left-hand side, I mean, you could write this out if you want. You could write out 5x equals 0. And then to solve for x, we would divide both sides by 5. That's supposed to be a 5. So it leaves me with x equals, and 0 divided by 5 is just 0. So there's my first x value. Okay, and then on the other side of the t-chart, I'm just going to jump right to it. We know we get x equals positive 4, right? We get the opposite sign of what our factor has. Okay, so those are our two x values. Now we need to find the y values that correspond, and you can use any of the equations. You can use this one. You can use this one. You can even use the one that we created. Since we're solving for y, I think this one's the easiest, right? Y equals 2x minus 5. So I'm going to do that. Y equals, let's start over here. Y equals 2x. So in place of the x, I'm going to plug in a 0, right? Because right here, x is equal to 0. And then I'm going to write minus 5. All right, so 2 times 0 is 0, and 0 minus 5 is negative 5. So we get y equals negative 5. So when x equals 0, okay, right here, y equals negative 5. So 0, negative 5. Okay, and then let's go to this side. So when x equals 4, I'm going to use the same equation, y equals 2x minus 5. I'm going to replace this x with a 4. So y equals 2 times, instead of x, we're going to put a 4, and then minus 5. Okay, so y equals, well, 2 times 4 is 8, and 8 minus 5 is 3. So we get y equals 3. So to write that as a coordinate, right, we do the x first and then the y. We get 4, 3. Now you could do one of two things. You could either just box off these two answers, because this is one answer, right? And this is the other, so you could box them off. Or if you want to just, kind of put them in a solution set, group them together in curly brackets and say, this is my solution set, you could do that as well. Either one is fine, okay? But just again, if you prefer to just be like, all right, this and this, these are my answers, box those off, that's fine. As long as you make clear what your answers are.